Howdy, everybody in YouTube land. What we have in front of us today is a Macintosh SE 30 reloaded board, another one. Now, this one came from Colin at This Does Not Compute YouTube channel. If you haven't checked out his channel or seen it before, I highly recommend you do so because he does some very good, in depth, detailed videos. And he's a really popular YouTuber, so he gets a lot of good content up there on his channel. Now, this particular board is part of the lot of SE30 boards. There was a group buy, and there was a bunch of these made, and he is doing an in-depth video on the SE30 Reloaded. I'm not sure if he's going to have it released in time for Macintosh or not, but he's going to have an in-depth video on this particular project with how many of these you can build with as many new parts as possible and stuff like that. I'm not entirely certain what it's all going to be about, so you should check out his channel and have the notifications on for when this video drops on this particular project. However, so here's the story with this one, and I think I kind of know what's going on with it, but I will give you the history first so we know, that way you're up to speed. So there was a group buy of these particular boards, and this board doesn't work. It doesn't boot or anything like that. Now, it could be the soldering, it could be one of these chips bad or something like that. That's kind of the first things you think of, right? But he's already went through and replaced all of these chips from a known good board. He's already swapped this chip from a known good situation and all of this. So all of these chips are good. So we know it's not a circuit problem with the chips. And all of the 74 series components are brand new from JLC, because JLC is the people who made this board and did the PCB assembly. So it could be one of those that are bad, I don't know. So, or the wrong ones placed in the wrong positions, but I think we went through all of that. So it could be this particular board, or it could be his process of building this board or whatever. That's what I would think if it was just the one board that's bad. But then there was a mention that there's a second person who had a problem out of the group buy and was having a similar issue. Could be a fluke, right? So we start going through things, and then I find out in another Discord server that there is a third person that has one of these boards that does not work, and it got sent off to Big Bad Biologist to look at. Now we have a pattern, right? So now we've got an issue with these boards. I guarantee they're all going to have the same problem. So that kind of changes my line of thinking a little bit. So I started mentioning in the group chat with Colin, check the bird seed. And what I mean, what does bird seed mean? Bird seed means all these little surface mount resistors and capacitors and transistors and stuff like that. Things that were dropped on from JLC during manufacturing. So there could be two possibilities. They could have used the wrong bird seed, and I've seen this before with my own personal experiences when I'm dealing with Chinese PCB assembly. I've had them outright use the wrong components entirely, and I've also had them use counterfeit components with boards. So anyways, can't roll that out. So check the bird seed, but the other thing is check for physical damage, because Colin did mention that these boards were not packed properly from JLC and that they kind of got damaged in shipping. So we've got issues along those lines as well. So we need to double check everything on this board and make sure we don't have any damage to any of the components, because I can already tell right away we've got a pretty gnarly scar right here. That could be an issue. This board is really sticky, but it's all the flux residue. But yeah, I need to check all of these capacitors, which they all look the same, and I think the bill of materials, they all call for them basically to be the same, except for in a few instances like over here, and there might be something over there that's a little different. But the other thing too is the resistors themselves, to make sure they are in the correct positions with the correct identifying marks. So we have to double check all of that, right? And the third thing we need to check is we need to check the semiconductors themselves, like the ICs that are on the other side, the resistor packs to make sure they're in the correct spots and the correct values, and then these little diodes and stuff like that. We got to make sure that those aren't shorted and that they're the correct ones to be put in the correct spots. Just like over here, we got to check those. It looks like that one got damaged, so that had to be patched up. So we got to check those. We got to make sure the right ICs are in the right spots here. You know, upon first glance, it kind of looks like that they are, but I don't know until I look, you know, double check all of that. None of the components are on here, so I'm not going to be able to check this board if it's booting because I don't have any of the ports. But I can check that it's, you know, posting, right? That we're getting through the ROM process. That's the most important thing. Looks like that got a little bit damaged during the rework process of that IC. That's not a big deal. That can always be replaced. I'm sure this board will be cleaned up and replaced before he features it on his videos anyways. So because he's doing an in-depth video of the reloaded build, I'm probably not going to go into too much detail on this. I'm just going to go through my process of troubleshooting to find out, okay, where do we start? So given the history and the testing that's been done, I had him send this to me, which is a cool little nifty tool that goes in the ROM slot that has LEDs on it, so you can see if it's walking the bus and stuff like that, right? So we can see that, and that's kind of cool. I like that. So we'll take a look at this a little bit later. So I'm doing my first glance, and I'm not really seeing anything that's standing out to me. Again, I've got to go compare another board to make sure the right chips are in the right spots. You know, we got the right resistor packs, which it looks like they are. This one's going to be different because I think this is a 1K pack, and it is. These are all 220 ohm packs that are straight through, that couple up to the RAM itself. Those look fine. The Sony ICs are there. These I don't recall. I have to look. That's the SCSI. That's right. 8530s, the SEC. That's right. Let's see. Is this the 60? Okay, yeah, that's the ASC because the 61 is the swim, and that's right. So all of that stuff is right. There's the Vias. Those look new or newish. They're not the Apple brand ones, but that might be okay. I mean, I don't think there's any specifics there with that. Also, I've noticed the Bourne's filters are these aftermarket networks, so I think these are no longer available. So there's a project that came out where you can make new ones. In an ideal world, you should rework the Gerbers and have those on the physical board itself instead of these. But I think this board was based on the original design, which you would just move all your parts over. But if it's probably there for somewhat of originality purposes, but this board is far from original anyways. So I figured, well, why not just put all of this on the board itself? Maybe even get rid of the 30-pin SIMs entirely and put a 72-pin SIM there, because it's far easier to get 72-pin SIMs than it is 30 pins. So anyways, that's just a little nitpicky stuff, not a big deal. Alright, well, let's take a look at this particular board and double check everything going on here. That's pretty rough. I'm going to have to buzz out those connections and make sure they're actually good, because that's a problem. That's going right to the processor. So if that's broke, if that is actually broken through, it's not going to work, right? So we've got to test that. And we also have to look for any components on this board that have been chipped, scarred, scratched, you know, all of the basics, basically. Basics of basically. So that's what we're going to do before we get too carried away. Alright, so upon first glance, without looking at the schematics of the SE30, I'm not seeing anything stand out at me right away. I checked the connections between here. One of them goes over there, and the other three go over here, which is connected to the RTC, and they're all good. There is a missed solder joint there, but I can kind of still see solder in there, so I doubt that's my problem. Now, while I'm looking at this board, I noticed in the group chat, Kai Robinson had pointed out, because we were both looking at the birdseed pictures just to try to rule anything out, and he pointed out that these are labeled C8. So let me take a closer look at those, because when you look up C8 on the internet, that is not a diode, that's a PNP transistor. And these are supposed to be diodes. So if that is indeed the case, JLC populated the wrong components in that position. So let's take a look here. I'm going to reverse this around. So that doesn't look like C8, that looks like CB. So, okay, let me switch to the overhead camera and we're going to do some tests here. Okay, so we are on the overhead camera and I got the meter out so you can kind of see what's going on. Yeah, it's got crappy audio, but it is what it is. There's not a whole lot I can do about it. But anyways, so what I wanted to check is I wanted to check to see if this is a diode or a transistor. So we're going to check right here. That's not right. No. Nope. No. Ooh, yeah, that's... Alright, so... Okay, so let's switch over to the computer here and see what we got up on the screen. So, if I look up the code book, CB is right here. It's the only SOT23 that we have in that group. Now, I don't know how up to date this is, but that's what I got. So if I Google the BCW661BR, the first thing that comes up, if I look at this, let's see, let's take a look at you. PNP silicon transistor, that is not a diode. Because if we take a look at the SE30 schematics, here we go. This is in the RAM section, so let's take a look at you. Yeah, there they are. They're BAS40. These are Schottky barrier diodes. So these act as clamps. They try to clamp signal transitions and stuff like that without diving crazily into the theory. You can kind of see why this is not going to work. So we have pin 1. This is D4, which is right there on the bottom. So this is D4. This is, yeah. So 3 is connected to ground. At least I'm pretty sure it is. It is. 3 is connected to ground. At least how they have it shown in the circuit here. So this is a BAS40. BS40-6 general purpose dual Schottky diode. Let's look at the data sheet here. Just look at the pinout, because the pinout, see 1, 2. Okay, so this is how they have it set up. So 1 and 2 is in 3. Now, switching back to the camera here, what we know is this. So the way it's done in the schematic, it goes 1, 2, and 3 as we saw. But on a transistor, it always goes 1, 2, and 3. So on a transistor, this is the base, and a PNP. It's going to be on, black on the base, and then we have the collector here, and then we have the emitter here. Nope, I'm not getting anything on that, so maybe it's an NPN. I'm going to probably have to remove that. But before, I have my suspicions with that CB code. So, Kai pointed it out, and I'm double checking it. But before we go any further, let's get this board hooked up and just see what it does. Actually, it might be a false lead, because if you look, I think that code book is out of date. Because if I look at CB here, which is a SOT23, BAS4004. So that is, if this is to be believed, Again, there's too many discrepancies here. If this is to be believed, that is the correct component. So, alright, I wanted to make a correction here. So, when that site said it cross-referenced to a 4004, that is correct. Because if we look at the 4004, notice we have a series diode network when we need this one, the 4006. So yeah, the 4004, I wanted to make a correction on my statement, is the 4004 was not the right one. Because I was looking at the BAS 40 part. I'm like, it's a BAS 40, it's a BAS 40, it's the same thing. No, it's not. Because I'm noticing the suffix here, here, and here all matter based on the configuration of the diode. So that's what it was. According to that site, that diode cross-references to the right, or that part number marking code cross. I don't know. Marking codes are all over the place. But anyways, before I get started down a rabbit hole that I can get stuck in for hours, let's just give this thing power and see what happens. So I want to use this cool little new blinking lights thing because I don't know. This is cool. I'm gonna have to buy one of these. I got to get in touch with the seller because Colin gave me the lead on where he got that. So I'm going to get in touch with him and buy one of those because those are cool. Anyways, let's see what happens without the ROM. God, that's bright. It's walking the bus. It's doing exactly like it's supposed to be doing. So that's working. So let's go ahead and put the ROM sim in here. What in... That's not possible to put in there. No. You know, when I built my reloaded board, I couldn't find these ROM sim sockets. So that's why I built mine with the PLCC chips. But I guess they found the ROM sim sockets. So, alright, let's get you in there. Let's do this. Let's do you. And then you. The board's kind of thin. Alright, what does this do? No, that's not right. It's just locking up. But I'm noticing all of these are like grounded or something. It's weird. Yeah, that's not right. Not supposed to do that. My lord, those LEDs are bright. Alright, well, it's a great diagnostic tool, but it's not fun to get out. So let me pause this. Just for my own curiosity's sake, this board here worked. It had a bad UE8, and I fixed it, but the original owner didn't claim it back, so it got shoved in my collection. So, anyways, this is a spare SE30 board kicking around. It's got new sockets in there and a UE8. But as far as I know, this board works. So I'm curious how this behaves without the ROM in it, with no, in a different board. Let's see what it does. Well, that's a little different. We've got floating data lines. It's just looping the same exact addresses over and over again. But it is different behavior. Okay, so I think what I want to do now is I want to get some RAM in the reloaded board and see how the behavior changes as well. So let's do that. We got to get some kind of load on the bus. All right, so I got some RAM back in the reloaded board, and I got this tester in it, and it's pretty much doing the same thing. There's no data bits on it, and we're just walking the bus, which is expected behavior. Now, what I've noticed, the data bus is floating, as it should be, because there's nothing driving the bus right now. If I put my fingers on the SIM slots, if I'm on this first SIM slot, I get nothing, which is unusual. If I'm on the second SIM slot, I'll actually get, let's see, where am I at? If I'm on the second SIM slot, I'll get, bus activity. On the first one, nothing. Second one, activity. Third one, nothing. Fourth one, activity. Okay? But that's strange. I got data of this is floating, because if it wasn't, I wouldn't be able, my finger wouldn't do anything because my finger is acting as a resistor. I'm loading the bus with my finger, right? That's how this works. So I've got nothing here, but I do there. No problem. Nothing here, and then I do here. So, okay. I want to compare this to the behavior of the good board just to prove a theory, because I have a theory here, and it goes back to these diodes. So let me go grab the other board. Alright, so now I got the original board in, my board. Let's see what it does. This one has a stuck data bit high, which is weird. But anyways, so let me try. Stick 1. Nope. I got nothing on any of these. They're not floating at all. They are not floating. But then again, it's running the same segment of code over and over again. But yeah, it's not floating on this one. Oh, there we go. Now we got something. It's different behavior. Well, now it froze. Because it got bad data. Got a power cycle it. There's something wrong with this board. I might have a bad board here still. It's been sitting for a few years. So my control is not exactly the best. The first 2 sim sockets are not floating. The last 2 are. Well, there's something up with that. So, yeah, this has got different behavior. I need to find my reloaded board and see what it does compared to this one. Never mind. It's just this sim module is too thin. See that? So, now if I perform my test while holding the sim module, first sim socket, yeah, it's working. Second sim socket, yeah, it's working. Third, yeah, it's working. And fourth, yeah, it's working. Alright. Now that we have the proper control so I don't look like an idiot as much as I already did, all 4 sim sockets are causing these to flip when I touch it. Whereas the other one, I'm only getting 2 out of the 4. So we already know we have a problem there. And I'm going to start right at those diodes, because if we saw in the schematic, the diodes are clamping the data lines. So if I'm only getting half the data bus and not the other, we need to take a look at those diodes. So that's what we're going to do. Alright, so we know from looking at the schematic that these are clamping diodes. They're Schottky barrier diodes. And the data bus, if we have the pin connected to ground, I'm just going to find ground at one point here. There shouldn't be anything here or here on any of these diodes. And that's accurate. That's the way it's supposed to be. Now if I take and do U here and do the same thing, since now the diodes are going to be reverse biased, we're going to have current flow through it. Okay, that's accurate. And that's accurate. But the data bus is not going to be reverse biased, so you won't have a problem. This is normal behavior. That's expected behavior. Now we have our control, right? Now we're going to take a look at this board. So once again, if we find ground somewhere, I'll just pick a spot, find ground, and then we go on one of the buses. We'll just go over here. Nope, that bus is forward biased. That's the right reading. Wrong polarity. We go over here. We got some issue there too. This is not right. So let's take a look at something else here. I'm going to turn the soldering iron on. So let's take a look at something else. So if we go here, yeah, that's not. No. This is accurate. That explains why when I fingered this, nothing happened. But when I fingered this, it did. Because this side is accurate. This side is not. Because if I forward bias this side here, it's because, let's say, the data bus is always going to be positive in respect to ground when it's a digital 1-bit, right? So if I go a 1-bit, we're clamping it straight to ground. We're literally driving it straight to ground. So there's your problem. So even though these are marked CB and it shows that they're the correct diode on the website I just pointed out, it's not correct. There's something wrong here. Those are the wrong parts. So they're either mismarked from China or the information on the internet is incorrect. Something's wrong somewhere. So therein lies our problem. So what I'm going to do is I'm going to take one of these diodes off the board. I'll just start with this one down here. I'm going to take one of these diodes off the board and we're going to read it out of circuit. We're just going to read you completely out of circuit. Now, I don't know if you're going to be able to see this, but we're going to read you out of circuit. So we're going to forward bias you. Nope, that's not going to work. So let's forward bias you. Nothing. So we go this way. Yes, I see the problem now. Yes, I do. So, I see the problem. Let me draw it out. I'll see the problem. Okay, so if we have the diode body here, we have you, and you. What we're supposed to have is we're supposed to have you That's what we're supposed to have. This is the symbol that we are supposed to have right there. But what we actually have, here's what we actually have. This is what we're supposed to have. And that's what we actually have. That's not going to work because this side here is a problem. Because that's just grounding out half your data bus. Exactly half your data bus. So, here's what we're going to do then. I'm going to take off every single one of these diodes and then we're going to try again. Alright, so all of the diodes have been removed. It should still work in theory with all of these diodes out, but we're going to see. So, let's, alright, so now we're going to test this board again with all of the parts removed, and we're going to see what happens here. Just out of curiosity to see if we get a floating data bus now. We should get floating on all bits now that that's been removed. Imagine that. Well, it won't. It'll be 100%. It's not clamped anymore. Which, that's the way it's supposed to be. Without those in there anyway. So, okay. Let's see what happens. It may not run without the parts in there. Because I don't have any of those diodes on hand. I'd have to order them, but for now, let's see. Something's happened. No, we're not getting anything. It doesn't work without the those diodes in there. I was hoping it would. There's no reason why it shouldn't, but they definitely have to be in there. So, yes, they've got to be in there. I got to find my there's no buttons on this thing, so. Yeah, it's doing a lot more than it did. I'll give it that. But I need to get some diodes because those are the wrong ones. Alright, so I went ahead and hooked up the speaker so I can hear if it's doing anything at all. And let's see. Hey, it's running code. There we go. That was a lot better than what we had before. But we don't have proper RAM access. That slow chimes means it can't see RAM. So we've definitely got an issue in that department. I mean, we are missing the clamping diodes for the Schottky barrier, so that, you know, might be normal. But I'll tell you what I will do real quick, because this blinking LEDs thing is sketchy. I like it, I really do, and I want one, but I don't think it's gonna work like that in circuit. It might. But anyway, so let's just go ROM straight in, just to roll that out. Nope. Okay, so we've definitely got a problem with the RAM. Likely because we're missing the diodes. I'm going to have to go find some diodes and just put those in there to roll that out. Trying, but it can't see the RAM. But I'm sure that's not helping. Now, for the fun of it, I just shoved the ROMinator in there instead of the stock ROM, and we get a chime. And no death chimes, so, but even better, we actually have a working machine. Well, mostly. Now, I will say that it locks up right there. It doesn't go any further than that point. So there is still a problem with the hardware. But, once again, I don't have those diodes in there because I just don't have them. So, that, before I can even do any further troubleshooting, I've got to get those diodes put in there. But the good news is, the board's alive. It is booting. It's running the ROM code. It's initializing the hardware far enough to show a mouse cursor. So we're almost there. We're like just right there. So close. Alright, I went ahead and got some diodes installed. I just pulled these off of a parts board, which I used to build my Reloaded a couple years ago. So I just moved those over here for now, just to see, because I really don't think these diodes are necessary, but just to rule out the possibility that these can be an issue, we're just gonna do that for now. The other thing that can cause what is happening is the ADB chip not working. I've never seen one of these fail personally. I just know of people that have talked about it, including Kai, mentioning that the ADB is an issue on sometimes. So we'll have to see. We'll have to play that by ear. But alright, I got the diodes installed, so we're just going to go ahead and get this in the machine and see what happens. I really don't expect any change in behavior, but we'll know for sure. Yeah, I didn't really expect any change in behavior, but it was worth a shot just to see what would happen. Let's see what this one does, see if it gives me the same problem. We'll see. Got a mouse cursor. But nothing else. That is a fail. Alright, well, at least we know the diodes really didn't make a difference as far as needing to add them or not. So I didn't figure it would, but I just wanted to rule it out. So yeah, we have an issue with RAM access potentially, but I don't see that being an issue because we got a mouse cursor. The RAM's got to be working somewhat, or we have an issue with the ADB controller. So it's going to be one or the other. So we need to figure out exactly what is going on in that front. Actually, before I go off on a tangent and unsolder the ADB chip, because I still have the raster that's got a cursor and that's it, what I'm going to do is, because I can, because the way this board is made, I'm going to swap the vias, because the ADB chip is controlled by this via over here. So what I'm going to do is since we know the ADB chip, or the ADB is probably not responding, we don't know if it's the actual ADB or if it's the VIA. So I'm going to take a look at the pins here. They're fine. This VIA is also not original. It's from 1998, so these are replacements. And what I'm going to do actually is as crazy as this sounds, I'm going to swap them around between the two sides. Make sure they're in the right order. There we go. There we go. Alright, now, with the vias swapped between the two, I want to see if the problem moves elsewhere. How about that? Oh, no cursor, just a CMA CMAC or whatever they call it, which really all that is just the initial state of this memory. When it comes up, it's uninitialized. So there we go. We moved, the problem moved. So actually, our issue is probably right here. The problem is right there. Getting this in is fiddly. There we go. That's a problem. At least I'm thinking that's a problem because, yeah, looking at the schematics, which is right here, we have the ADC, or not ADC, yeah, ADB, which is this chip here, but it's going to UK12, right? And UK12 is right here. So I'm going to go find another parts board that I can steal a VIA off of, a 65C22, and we're going to drop that in there and see what happens. Alright, so we have a battery bombed 2SI board here that's just completely roached. This thing will never work again because these VLSIs are just gone. So it's fine. So we're just going to go ahead and steal the 65C22 off of this one. Hotter than Heckledorn. Ooh, yeah, that was smart. Alright, so we have you. Really warm. Ooh, wow. Trying to do this hot's not exactly easy. Alright. That should hopefully solve our problem. At least I'm hoping anyways. So that's the 65C22. There we go. Now, does it work? Or did I replace the wrong one? That's always a question, right? So here we go. Ooh. Ooh. Ooh, 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 ooh. Interesting. Okay. Interesting. So that's a strange one. So let me try this one. Would both be bad? I don't know. Oh, this is like a guessing game. I sure could dig out the oscilloscope and start chasing signals and all of that, but there's hours and hours and hours of time involved in something like that when it's just easier to swap the chip because it takes 5 seconds. So, yeah, see what I mean? Doesn't do it now. Maybe this is the one that's bad. Alright, we have a cursor again. I guess the question is, do we have anything else? And would you look at that? We have a blinking disc icon. So there you go. That VLSI 65C22 VIA was bad. I'm not sure where this one came from originally, but it's no good. Went ahead and replaced it, and now we're up. So the only thing left to do now is to try the original ROM and see what happens. Alright, now that we know the VIA was definitely bad, so we'll move you out of the way, I'll go ahead and put the stock ROM in and see what it does. Bingo! There it is. Stock ROM is working. Much faster too. This thing takes longer to load. Alrighty then, so we are golden. This board is fixed. It had two problems. One, it had the diodes were incorrect, which, I mean, if I would have left the diodes completely out and not put the parts ones in from the spare board that's over here, it would probably work fine. And then secondarily, we had this VIA that was bad. So it is definitely bad. Now, Colin said that these were tested in another board, and there's a chance that this was good. But then perhaps moving things around, a little bit of ESD, boom, that's all it takes. Done. So there you go. All right. So, just for curiosity's sake, I'm curious how this board works. This board works in this board with the stock ROM. So let's give this thing a try. Well, that's cool. It's moving so fast you can't really see. It's like it's testing a bunch of peripherals right now because the icon's not up yet, but that is so cool. And then looks like we've moved on in code execution, and we have. There's the floppy icon. So there we go. This board is golden. It's good to go. I think that's going to wrap this one up, ladies and gentlemen, because I can't go any further with it because I don't have the SCSI port or the any of that stuff, and it's not populated. So I'm just going to leave it right there, and Colin can handle the rest of it from this point forward. So if you enjoyed this video, and I hope you learned something, don't forget to hit the like and subscribe and all of that fun stuff. If you have a comment, please feel free to leave one. Thank you for watching. Until next time, guys.